All right, so we're going to start talking, the second half of chapter 10 is about probability. So the first half was on like bar graphs and different types of graphs. And now we're going to shift into probability. And we're going to start today by talking about experimental probability. So before we talk about that, let's talk about what an experiment is. So in terms of science, an experiment would be like you have to make a hypothesis and you're testing a hypothesis. When we use the word experiment and probability, we're just talking about an activity that has some chance to it. So chance means like you could get it or you could not get it. So for instance, rolling a dice is an experiment when we're talking about probability because it's an activity where you have a chance of getting 1, 2, 3, 4, 5, or 6. Okay? So when we say experiment, we're not talking about like setting up some intense experiment. We're just talking about doing an activity that involves chance. Flipping a coin is also one. Spinning a spinner. Taking a bag of like, marbles. If I put all your names in a hat and picked one out, there would be a chance there that like I could pick Brian. There actually be 2 chances I could pick Brian, right? So all those experiments are just activities that involve chance, okay? So the first thing we're going to talk about is sample space. And sample space literally is just a list. And it's a list of all the possible outcomes that could happen in an experiment. So when we do something like rolling a dice, our sample space is just the list 1, 2, 3, 4, 5, and 6, because those are all the possible outcomes. So then when you're flipping a coin, what's your sample space? Heads or tails, because those are your possible outcomes. When you're spinning this spinner, what are my possible outcomes? Yeah, just the colors, right? So it's literally just a list of those possible outcomes. Now, those are really simple experiments because we're only doing one thing. So the sample space is just simply a list of the stuff that's on it. But sometimes our sample space might be a little bit more complicated. So how would you figure out the sample space of flipping 2 coins? Like, what are your possible outcomes when you're flipping 2 coins?
Half heads or half tails.
So what do you mean by half heads, half tails? Okay, so maybe you could get heads or tails still 50%, but that's only just flipping 1. Sort of. Where's the 4 coming from? So there's 2 quarters, so there's 2 options on each quarter. Okay, so tell me about what could you get the first time? Heads, or you could get tails, so that's an option, right? But what could you get the second time?
Heads or tails.
Well, what if you flipped heads the first time? So you flipped heads the first time. How many options do you have for the second time?
2.
Still 2, right? Because you're still flipping a coin. So one of your options would be HH, which would be if you got what? Heads both times. So there's one of your options. What's another option? Tails is another option. What's another option? Heads, tails. Tails, heads. Good. Are there any other combinations? No? So that's it. So Victoria, you told us how many options were there? 4. But the sample space is what those actual options are. So I abbreviate so you don't have to put like the whole words. You can just put heads, okay? Now, this is your actual sample space. And using that sample space, we can answer questions like, what is the probability that I will flip tails at least 1 time? So what's the probability I would flip tails at least once? Well, how many times is there tails at least once? 3 out of 4. Because how many total options are there? 4. So this one has tails at least once. It has it twice, but that counts. This one has it at least once, and this one has it at least once. So we would say the probability of flipping tails at least once is 3 out of 4. Okay? But the sample space itself, if it just asks you for the sample space, that's just a list. Now, it's not too challenging. Like, I think this is a tough concept, but not too challenging to come up with this list, because you can really visualize a coin flipping 2 times. But sometimes our sample space is going to get pretty big. And so I'm going to talk really quickly about a way to organize sample space. And I'm going to use food to talk about it because it's my favorite thing. So we're going to pretend that we're at Subway. All right, but we're going to make it a really basic Subway because I don't want to make it super hard. But I want to figure out, when I go into Subway, the possible sample space for the types of sandwiches I can get. So when you first walk into Subway, the first thing you have to choose is what? The bread.
And if you want to toast it or not.
We're just talking the sandwiches here. So the bread is the first thing you have to pick. So give me three. I know there's more. Give me three options.
Italian cheesy bread.
Okay. All right. So bread is our first choice. So we've got wheat. Well, let's pick a different one because that also starts with W. So Italian.
Grain.
And then also starts with W.
Grain.
All right.
Herb.
There's an herbs and cheese one. Oh, the flatbread. Let's do flatbread. So we've got wheat bread, Italian bread, and flatbread. Okay, so So that's our first choice that we're making. So right now, our sample space is only 3, right? It's really small, okay? But that's not all you choose at Subway because no one goes to Subway and just gets a piece of bread, all right? You put some stuff on it. So the next thing you choose, you don't even pick toasted yet. Slow down. You gotta pick other stuff before you pick toasted.
What kind of sandwich you want?
Anthony, what comes next at Subway?
The meat.
The meat. Okay, so you pick the meat. We're only gonna do a couple of these so it doesn't get ridiculous. But the next thing you choose is the meat. So give me 2 options for meat. So pepperoni or turkey. Okay. So next we'll choose meat. And we're doing we're pretending this is a really, they're out of stock. So all they have is pepperoni or turkey. So what I'm gonna do here is I'm gonna create a tree diagram. Because for every time, for wheat, you could pick pepperoni or you could pick turkey. But if you pick Italian, you still could choose pepperoni or turkey. And if you choose flatbread, you still could choose pepperoni or turkey. Okay, so here's our tree diagram. We've now made our second choice. Now, how many things are in our sample space?
6.
2. Well, no.
6. Why is it 6?
Because you're having 50-50 chances of getting whatever. One of each
Okay.
meats.
But how come it's 6 and not 9? Because I count 9 things up
Because
here.
the 3 of the rest of their breads.
Okay, so you have to pick a bread and a meat, right? So you count the farthest row. Okay, so then that's our meat selection. So then after meat, what do you choose? Cheese? Not yet. You gotta do cheese. I'm a cheese person. So let's do 3 options for cheese. Swiss, American, and cheddar. Swiss, American, and cheddar. Okay, so that means I put Swiss, American, and cheddar. But do I only put it here? No. I put it on everything. Good.
We really did. Yesterday.
Good. Then you should know just what we're doing. Okay. So, how many so we're going to stop here. I understand if you're at Subway, now they'd ask you if you want it toasted, then you ask vegetables, but I don't want to make the largest tree diagram ever, so we're going to stop here. But the question that we're answering is, what is our sample space? So we've got to figure out our sample space. So how would you figure that out? First of all, how many sandwiches are in our sample space?
1, 2, 3.
8 cities.
18. Why are there 18? Why are there 18?
Because you had
He's not counting
You had 3
You
options.
don't count the meat row because you assume that you're not just going to Subway and getting a pile of meat, right? You're getting bread, and I understand. You're getting bread and meat and cheese. Okay, and yes, I understand some people might say they don't want cheese. I get that. Let's pretend we're in a perfect world where everybody's getting the same type of sandwich. Okay,
Just get meat with cheese.
you're like on a paleo diet, you want a lettuce wrap? Okay, then you get a salad. All right, so we have 18 options, but sample space isn't just the number 18, it's a list of your options. So what are my options? What's my first option? Victoria?
Whatever the P is, pepperoni and Swiss.
Okay, sort of. Wheat, pepperoni, Swiss. So that's my first option. Again, I'm going to abbreviate because if I wrote it all out, it would take me a year. What's my second option?
With pepperoni, American.
Good. WPA.
WPT.
And then
Pepperoni, cheddar.
PC. Good. So that's my first set of options. What's my next option?
WPS.
I'm doing all the same thing except with turkey And now what happens?
And now you start.
Now I'm done with my wheat sandwiches, right? Now I move down to Italian, so it's
IPC, ITS, ITA, ITC.
all right. And then what else?
FBS, FBA, FBC, FTS, FTA, FTC.
Good. Okay. So how many options did we say we had? 18. We have 18 options. That's my sample space. I'm not going to ask you to create sample spaces that big most of the time, but in case you need to, that's how you do it. So you'd create a tree diagram to do it. Okay? So that's called a tree diagram. Why?
Because it looks like a tree.
Yeah, it kind of looks like a tree, right? So it kind of looks like there are branches coming off of a tree. Okay, so when you're looking at this sample space, now I might ask you a probability question of something like, what is the probability that I make a sandwich with American cheese? So what would be the probability?
3 out of 18.
No.
No, you have to add
6 out of 8.
Where, Micah?
And the wheat, there's 2.
Oh yeah,
1, 2.
And the tie.
Oh yeah.
So that the probability of choosing a sandwich with American is 6 out of 18, which becomes what? 1 out of 3. 1 out of 3. Okay. So that's sample space. Sample space is not a number. Sample space is a list. Probability is usually recorded as a fraction. What do you have to do with fractions? Reduce them. Okay, this is just a quick aside because I always tell the story when I teach tree diagrams. But when I was teaching in Chicago a long time ago, did you guys take, like at some point, have you taken state testing?
Yeah.
So like star testing. So whatever it was, whatever you took. Okay, so when you take it as a teacher, we are not allowed to like I can't answer questions at all. I'm not supposed to read. I'm supposed to like walk up and down the aisles like pacing to make sure that you're doing what you're supposed to be doing, right? So I would see the answers that kids were giving, but I couldn't do anything. Like I couldn't be like, hey, that's not right. Like, or you can't ask me a question, right? So it's very serious, whatever. So the free response section was like create a tree diagram for something like this, like something about t-shirts, and like you can either have a long sleeve or a short sleeve. It can be red, blue, or white, and you're supposed to make a tree diagram. So I'm like walking around and I see most everyone's like doing what they're supposed to do, and I was like, yes, like they're really getting this one, they're gonna do well. And I get to this kid Tavares, and I love Tavares, but I get to him and I see him working like super hard, right? And I look down and he has literally drawn, it is like a scene from a forest. Like there's a tree, but there's t-shirts hanging from the branches in the tree. Like, I'm dead serious. And I just have to keep walking because I can't even be like, dude, come on. Like, my job depends on this. Your scores depend on this. Like, and he clearly just didn't know what a tree diagram, like he didn't remember. So he was like, well, I'm going to draw a diagram of a tree. And he did, and I guess it was technically right. But, oh man, I don't think he got any points for it. But it was one of those moments where I was like, I mean, good for you, dude. Like, you're kind of right. You got a tree, and there's some t-shirts in it, but it's frustrating. All right. So if you guys are asked and you have no idea what to do, don't draw a tree. But anyway, so this is our tree diagram, which allows us to have a sample space. So here's our sample space. Again, most of the sample spaces you guys are going to do are a lot simpler, just like a dice or like a spinner. Okay. So probability is just the measure of how likely an event is to occur. So we call this on a spectrum, and a spectrum just means what?
Like
A line, okay, and what happens along that line?
Things happen.
Yeah, things happen. If something occurs on a spectrum, that means like we say,
Like along the line.
yeah, along the lines of, or like across a range of things, right? So this spectrum goes from absolutely impossible to completely certain. And this is called our probability spectrum. So down here, the probability of something that's impossible, we would call 0. The probability of something that is certain, we would call 100%. Everything else is somewhere in between there, somewhere on a range of that, okay? So every probability event you can place on this probability spectrum. The words we use, impossible, unlikely, which means it's between 0 and 50. As likely as not just means exactly 50%. likely means it's more likely to happen than it isn't, and certain means it's 100%, so it's definitely going to happen. Okay? So I'm going to try to think of an example. So what is the probability that you would have pizza on a Monday in the cafe? Certain. Why?
Because we do
Every single Monday, they have pizza in the cafe. So it is 100% certain that you will have pizza in the cafe. Good. Okay. So I want an example of something that is impossible. So I want to come up with an example of something that is impossible. So can anybody think of the probability of, go ahead.
You put in like in a sack, you put three blue.
Okay.
3 blue bean bags.
Okay.
And 3 green bean bags.
Okay.
The probability of getting a purple.
Good. Did you guys hear what Brian said? Because that was a really good example. So he said in a bag, you put 3 that's hard to say. 3 blue bean bags and 3 green bean bags. What's the probability you will pick a purple one? And that would be 0 because there are no purple ones in the bag. Okay? So impossible is 0. Certain is 100%. What's something that's unlikely? What's something that's unlikely? So again, unlikely being like closer to impossible, but not impossible. Victoria?
Getting a hurricane.
Okay, so having a hurricane, maybe even to make it like, because we live in Houston, let's make it even a little more unlikely and say like you live in Chicago. All right, so the likelihood of getting a hurricane in Chicago this year. Is it absolutely impossible? No. But is it unlikely? Yes, because they don't really get hurricanes there, right? Okay, give me something that is as likely as not. So 50%. Flipping a coin. That's like the example most people choose for 50% because flipping a coin is heads and tails. I understand in some weird gravitational moment a coin could technically maybe land on its side, but that like we're living in the real world where mostly you flip it, and so just don't fight me on that. All right, 50%. Okay, can anybody think of another one that's 50%? Giovanni? I think that's probably somewhere on the spectrum that we can't really assign. Because I don't think that's as likely to happen as not.
Miss Burn getting mad if you don't do her work.
No, that's 100%. Yeah. Okay. All right. What about something that's likely? Likely but not certain.
Getting rain the next day at Houston.
Okay, so getting rain like especially during this time of year, right? So that's probably likely. Usually it's more likely to happen. Okay, that's a good example. What is something like? Could I say something like? It is likely that the food in the cafe will be good.
Unlikely.
Even
That's
like,
impossible.
can I even put that on the spectrum though?
Not really.
Why not?
Because
Because it's an opinion, exactly. It's my personal taste. I might really love the quesadillas, right? Like I might like the food that you might not like. So if something's an opinion, you can't determine the likelihood of it because it could be different for everybody, right? So things that you like or don't like, I'm trying to think of like, what's a band or a TV show that like some people like and some people hate?
Vampire Diaries.
Okay, Vampire Diaries, something like that, right? But like if you say Vampire Diaries, like what's the likelihood that Vampire Diaries is a good show? But I only ask people who like Vampire Diaries, they're gonna say certain, but people who don't like it are gonna say 0, and that's not accurate. So you've got to pick things that are not opinions.
Like a little bit.
Again, debatable, but it's all like if it's an opinion, you can't really say one way or the other. Okay. All right, so we can use these words, impossible, unlikely, likely, or certain, to estimate how likely an event is. And then again, likely as not is when things are halfway. So you can also just say 50%, that's fine. So what is the likelihood of having 31 days in August? Certain. Why? Because there are 31 days in August. So no matter what, there will be 31 days. Okay? So yeah, I know. So there are 31 days. I had to like count it in my head during the last class. Okay. What about Carlos has to guess a number between 1 and 1,000? What's the likelihood that he'll get it?
Unlikely.
Uncertain.
Not uncertain, but unlikely. Why is that unlikely?
It's not important.
That's a big number.
It's not impossible, but there's a lot of choices there, right? So the likelihood that he'll get it on like the first try is pretty low. So we would say unlikely. All right. what about that a coin lands heads up?
50%.
50%, so as likely as not.
Next one is possible.
And then Cecilia rolls a 10 on a dice. Impossible. Why?
Because they have a 10.
On the left,
No, so again, we're assuming that every dice that we're talking about is 1 through 6, okay? So for this class, we are using a standard dice 1 through 6, so that would be impossible, okay? So we're not. So when you are doing any experiments in this class, and again, when we say experiments, we're just talking about like things that are happening. We're talking about a dice that goes 1 through 6. Okay, so before you go up, numbers 1 and 2. First, you're identifying the sample space, so you should give the list. And then you're giving the probability for the outcomes that are shown, so that should be a fraction. So this would be, what's the probability of rolling a 5?
1 out of 5.
Guys, you're doing this at your boards. And 2 is what's the probability of it landing in A. All right, here you're using the words. So don't forget your sample spaces for the first 2, go. Okay, so... All right, so let's move on. So then we're talking about experimental probability is when you actually do an experiment to test the likelihood of an event happening and you record your results. So experimental probability is the number of times what you want to happen happens over the number of possible outcomes that you had. So what you guys just did, those fractions that you put for the first 2, those are that's probability. Experimental probability is if you actually conduct some type of experiment. We're not doing experiments here, but we're using tables and charts and data to imagine that those experiments are done. So here in this experiment, they spun a spinner. What was on the spinner?
Numbers.
Red, blue, and green. And this frequency table tells me what happened how many times did they spin red? 7. How many times did they spin
8.
blue? And green? 5. Okay, so how would you figure out then what it should be out of?
You add them.
Why is it 20, Brian? Okay, so to figure out your denominator, which is the number of trials, or basically how many times you did the thing. So in this case, we're talking about spinning. So I spun 20 times, and I know that because I add those 3 together. Okay, so you add those 3 together, and you get 20. So then to say what is the probability that the spinner lands on blue would be what? 8 over 20. Good. And then what do you do with that? By what? 4, so 4 goes into 8 how many times? And then 4 goes into 20? 5 times. So the experimental probability here is 2 over 5. Okay? And again, experimental means we actually did an experiment. We, being this dude who did the spinner, we are just imagining it. Okay? All right, what is the probability the spinner does not land on green? Why 15, Ash? You have to add together the not green stuff, right? Which in this case is blue and red, which gives you 15 over 20. What does that reduce to? 3 over 4. Good. So the probability of getting not green is 3 over 4 because not green would be red and blue, which is 7 plus 8, which gives you 15. 15 over 20. And it's always out of 20 because that's how many times they did the experiment.
I didn't understand why you divided it by 5.
Because 5 goes into 15 and 20.
No, I mean, oh.
So I'm looking for a number that goes into both of them. 5 goes into both of them, so I divide by 5 here and divide by 5 here.
The biggest number?
The biggest number, yeah, the GCF, greatest common factor, that goes into both of those things. So you reduce it by that. Mm-hmm. Okay. All right, so at your boards, do these 4